Welcome to Physics in Sports. Today we are covering a volleyball game from 2013.
This game is between Wisconsin and Texas.
Oh, look, she hit that ball too far. Let's analyze the clip.
Let's rewind.
The court is 18 meters long and the ball used in this game has a mass of 0.28 kilograms, but she hit the ball about 19 meters far.
Sarah from Team Texas hit the ball at the acceleration of 1.85 meters per second squared, which means she hit it with the force of 0.518 newtons. This is the beginning of another exciting match. Allison from Team Texas has the ball.
Her serve demonstrates the conservation of energy.
The elastic potential energy from her arm transfers to the volleyball when she serves it.
The elastic potential energy then becomes gravitational potential energy when the ball reaches its peak.
The gravitational potential energy becomes kinetic energy. Look, now it is being battled with an unbalanced force. Team Wisconsin bumps the ball for the setter.
This is a perfect example of the conservation of energy. The elastic potential energy from our arms transfers into the ball as gravitational potential energy.
The volleyball's height is 3 meters from her arms. The acceleration of gravity is 9.8 meters per second, and mass of the volleyball is 0.28 kilograms.
That means her GPE is measured at 8.232 joules.
The ball's GPE then becomes kinetic energy as it reaches its peak and falls from there.
And remember, all energies are equal, so the kinetic, elastic, and gravitational potential energy are all equal to each other.
The law of conservation of energy states that the energy is not created or destroyed, but takes on different forms.
Remember, every form of energy, including work, are measured in joules. Hey, do you know that volleyball players work to hit the ball?
Obviously, they have to exert force on the ball to make it go a certain direction and distance.
Yeah, that's work. Work equals force times direction in meters.
You know, these girls are really aggressive when they attack the other team with a spike.
Yeah, it's happening right now.
She hit the ball 6 meters far from her hands, following the path of the ball to the ground.
The acceleration of the ball is 10 meters per second squared, and the mass is 0.28 kilograms. So her force is 2.8 newtons.
So that means that her work was 25.2 joules.
That's quite some work she's doing on that ball.
Team Wisconsin takes on the honor of serving. We can see here as Ellen steps up at one end of the court.
Wow, look at that serve. Her serve showed Isaac Newton's first law of motion as well as Galileo's law of inertia.
Yes, the first law of motion states that an object in motion will stay in motion at a constant speed and in a straight line.
But we don't see that when Ellen serves, do we?
No, ma'am.
That's where Galileo's law of inertia comes in, which states that the first law of motion will stay true if there are not any outside forces acting on the ball, such as somebody else's force, gravity, or air resistance.
That's a lot to remember. Let's look at her serve again. As you can see, the ball does not travel at a constant speed, nor does it move in a straight line.
That's because gravity is pulling downwards on the ball, and air resistance exists on Earth. So the ball will continue its path downward until it touches the ground and stops bouncing.
Or another player returns the ball. Force is recorded in newtons. Volleyball, like all sports and day-to-day activities, require force to move objects and your own body.
Many volleyball players run up to their spikes, so they are more powerful.
So what does it take for you to run up to the ball?
The equation is force equals mass times acceleration.
Her mass is 75 kilograms. Her acceleration is 2.47 meters per second squared, so her force would be 185.25 newtons.
Do you also know what volleyball players do to have a powerful spike?
What?
They jump up so they can spike downwards on the opposing team.
Yeah, but does physics correspond with that?
Newton's third law states that the forces come in pairs. Object A responds to object B the same way, with the same amount of force but in the opposite direction.
Oh, so the volleyball player's force to jump goes in the floor and the floor pushes back on her so she launches in the air?
Exactly. This match shows somebody spiking a ball.
Even when you don't know it, physics is always around you. So that's all for today. Tune in next time for Physics in Sports.